Alright, how's it going, folks? Today we're going to chat about Earth's history and some techniques scientists have used to try to figure out how old things are and try to put things into perspective as far as spanses of time, because it really is mind-blowing if you think about the amount of years we're talking about when you're talking about age of the Earth and changes over time. Alright, so that's where we're going today. Check out this picture up top, kind of like a tornado of Earth's time, right? All the way at the bottom here, you have the estimated age of the Earth, about 4.6 billion years old. And you have the oldest rocks and the simplest life forms. And as you go up, all the way today, you can see there's a little person at the end there. Well, that's you and I. And that's present day. And this whole spiral represents all of Earth's history, about 4.6 billion years. A simpler way of looking at it would be more just of a straight timeline, right? A linear timeline there, and there it is, about 4.6 billion years ago, formation of Earth. And Earth cooling, and gradually simple life going into the complex, and there we are at the end, which is to present day with modern humans. But the theme of simple to complex, you're going to hear repeatedly, right? That's the idea of evolution, change over time, normally from a simpler to a more complex creature. Okay? Alright, so in your notes there's 8 pictures. You have to try to put those pictures in order from simple to complex, if you will. Take a look at the pictures, try to common sense it, or, I challenge you, of course, go to the reference tables, and if you're not sure of certain ones, see if you can find where they are on the timeline to put them in the proper place. Alright, so hit pause, and let's see how you do. Okay. So here we go. Hopefully the first one you had was this simple bacteria-looking thing here. Okay. And you look, you're about 580 million years ago. You look on your reference table and you'll see simple types of life forming. After that, you have your trilobite, right? Life getting a little more complex. Hard parts. Hard parts favor fossilization, whereas these soft, slimy creatures, not so much, right? Keep going. The third one there, right? Ancient fish, right? Bony fish. Their skulls were quite different. Not like a modern fish at all. More of a bony skull, and they seem to have gone extinct over time. Then, of course, everybody's favorite, the insects. Yeah, they've been around a long time, about 420 or so million years ago and counting, right? They're still around. Next up, you have the amphibians, and you can see life kind of getting more complex. Amphibians have the ability to be in the water and on land, right? Then, of course, you get to the dinosaurs and the reptiles. They are a little more complex than amphibians. They could stay on land longer. Or their entire lives, and the age of the dinosaurs right in there. Then, of course, we get to mammals, and, of course, after that, modern mammals, and today, of course, that's a modern human skull. So a little timeline of Earth's history, and also, of course, evolution right there. All right. So how is Earth's geologic time scale divided? If you take a look, you have these funky-sounding words here, right? It starts out with an eon, and that represents the greatest spans of time, right? The bigger the box, the more years that are in it. Then you go to, Then you go to eras, periods, and then epochs. And within each one, you have fewer and fewer years. It's kind of more narrowed down. Okay? All this is based on fossil evidence. Your reference table perspective of it, take a look. So here's the eons. You have the Precambrian and the Phanerozoic. The Precambrian represents about 88% of Earth's history, but it's also the percentage that we know the least about. If you think about it, it's so long ago that you have a lot of weathering and erosion that would have destroyed a lot of that evidence. The creatures back then that existed were soft-shelled, slimy creatures. They don't fossilize well, so there's not much evidence of early Earth. But then comes what they call the Cambrian Explosion. Right, the beginning of the Phanerozoic eon starts with the Cambrian period, and that's when you'll see bodies start to develop hard parts, exoskeletons, shells, things that make good fossil imprints and leave evidence behind. Then you get into your eras, right? Paleozoic meaning ancient life, Meso meaning middle, Cenozoic meaning recent. The ancient life comprised of all of these periods down here, right? That's how you break it down next to periods. The Mesozoic is your dinosaur age, if you will, the Cretaceous, Jurassic, and Triassic. Okay. And I think we had mentioned this before, but the movie you've all seen, right? Jurassic Park really should have been called Cretaceous Park, because most of the dinosaurs in that movie were from the Cretaceous period. They were the bigger dinosaurs, but I guess Jurassic Park sounds better than Cretaceous Park. Anyway, then there's us today, right? The quaternary periods when we're living. But we could break that down into epochs, right? So you and I, modern humans, are from the Phanerozoic eon, the Cenozoic era, the quaternary period, and we're in the Holocene epoch. Earlier humans lived in the Pleistocene, and that would have been coexisting with mammoths and saber-toothed tigers, right? The classic cave person you're thinking of, that would be the Pleistocene, but modern humans are the Holocene. Okay? And this chart has a lot of information on it. You can read across. It's a little trickier to do on the PDF files because it splits the page in half and you're kind of going up and down. But when it's laid out like this, it's real nice, right? The hard copy of the reference tables is the best way to view this chart because you can go left to right real easy. Okay? And there you have your Precambrian down there. You can never cross this thick black line. A lot of students make that mistake. They'll come back across and say, okay, up right here. No. You got to follow the slide up. This whole piece is down here, but they try to squeeze it onto one piece of paper, so the spacing doesn't represent the same amount of years as it should. Okay? Okay. Then there's your Phanerozoic eon up top. This comprises the bulk of the tables because it's what we have the most evidence about, right? The last 570 or so million years, we have the most fossil evidence from. Therefore, it takes up the most space on the chart. Okay? All right, there's your Paleozoic, your Mesozoic, and your Cenozoic. And all of these things can follow across here. When you get to these lines in the middle, if you get into a break in the line, well, that means that evidence is missing. Fossils weren't found at that time. So, for example, let's see, look at trilobites. A, B, C, all of a sudden, boom, gone, right? There's no more after that. Well, the idea is they went extinct. So, of course, there's nothing more after that. But then you have another situation here, like the graptolites, J, K, all of a sudden nothing, and then L, so you have missing space there, and there's a thing called an unconformity where there's a break in the time sequence. Okay? But anyway, so for all these blanks here, we have no fossil evidence of that. All right? The letters here correspond with the letters on the bottom. Those are called index fossils. They're kind of like easy to identify, unique fossils to the area. They're kind of used as like mile markers. All right? And of course, you're familiar with this side when we talked about Pangea. You can see the placement of the continents at that time. And over here is what type of tectonic activity was going on. Mostly mountain building. They call that orogenies, mountain building episodes. Okay, orographic lifting is when a mountain forces air to rise. Well, an orogeny is when the mountain itself rises. Okay, so lots of information on this chart. What I'd like you guys to do is hit pause, of course, and try to go through some of these questions here based on this chart. Okay, geologic time, life on Earth. I kind of put them in groups for you to make it a little easier for you. All right, we'll come back. We'll go through this, and I'll meet you in the meet.